Hey everyone, welcome to Notes 1.09. Things are working a little bit differently today. We are moving ahead in the next notes page. It's relatively short. However, your classwork assignment might be a little bit longer today. It's going to be classwork 1.08. So let's get started. Looking at our notes for today, we have again some more equation of a line, y equals mx plus b, and so on. But today we're going to write the equation of a perpendicular bisector. All right. And some formulas we're going to need at the beginning here is just like what we were writing out on our notes last class. So slope, remember, is m equals the fraction y2 minus y1 over x2 minus x1. Our midpoint formula is when we take the x's and add them, x plus x divided by 2, y plus y divided by 2. And our point slope formula was new for some of us last time. It goes y subtract y1 equals m times x minus x1. We're going to be using all three of those formulas today. So here's like a step-by-step process to do these questions. I know some of you do well with being told what to do first, second, third, and so on. But when you're asked to write the equation of a perpendicular bisector, so what that is, let's just think about what those words mean to us. We're going to be given two ordered pairs for a segment. Let's say that segment is AB. And we're going to have to be writing the equation of a line that cuts that segment in half. It's not quite the halfway mark. Let's try that again. That cuts that segment in half, and a segment that runs perpendicular to it. So AB is some two ordered pairs given to us in the coordinate grid. We're trying to find the equation of this sketched in line here that meets at the midpoint, right? It bisects it into two equal pieces. So we're going to need to locate a midpoint. And if we knew the slope of AB, this new blue line here, its slope is perpendicular to AB. So the steps to find this. First, we're going to calculate the slope of our line. And we're going to need our y minus y1 equals mx minus x1. Then we're going to determine our slope perpendicular. So that's when we're going to find the negative reciprocal to that equation. Okay, we practiced that last time. Third step is to find the midpoint, which we wrote in up here. Because again, we go through the midpoint. So again, we're trying to write the equation of this line, and we'll have a point, the midpoint, and the slope perpendicular. So in step 4 here, we're going to substitute the slope perpendicular from the second step and the midpoint from the third step into our point slope formula, which is that y minus y1 equals mx minus x1. Lastly, if necessary, we're going to solve for y equals and put it into slope intercept form. So here I'm going to graph example 1. All right, so example 1 says write the equation of the perpendicular bisector. Okay. So write the equation of the perpendicular bisector. Now each phrase there means a formula. Equation of a perpendicular bisector is our point slope formula. And the point and slope come from the word perpendicular, meaning our slope perpendicular, and bisector, meaning the midpoint. So each phrase in those directions mean a formula for us. So write the equation of the perpendicular bisector that goes through the line segment with endpoints 2, 1, which is going to be point A. I'm going to graph that. And then 6, negative 3 is point B. So there's our segment AB. Now again, what we're trying to find the equation of, and I'm going to just kind of sketch this in yellow, We're trying to find a segment that cuts AB in half and is perpendicular to it. So we're trying to find the equation of this yellow line I kind of just sketched in here. Now that's just visually a bisector that cuts AB in half, and those two lines are perpendicular. So the perpendicular bisector is a segment that bisects and runs perpendicular to another. Okay? So the steps, again, that we just listed out, first thing we do is find the slope. So step 1 is to find your slope. Step 2 is to find the slope perpendicular. Step 3, we're going to calculate the midpoint. And then step 4, we're going to substitute into our point slope formula. So as I wrote those out, I'm going to do the workout kind of in a different color. So our ordered pairs are x1 and y1, x2, y2. So our slope is going to go y2 minus y1. So again, the formulas are up here at the top of the screen. Trying to color code to keep us all in check. So slopes I'm going to do in blue, midpoints in purple, point slope in red. So looking at those first ordered pairs, x2 is -3 minus x1 here is +1 over that's y2 minus y1 over x2 is 6 minus 2. And that slope would be -4 over 4 becomes just -1. Now the slope perpendicular, let me erase because I kind of didn't leave myself enough space here. Sorry about that. I'm going to rewrite those in as I go. So step 2, our slope perpendicular, we're going to take that -1 and take its negative reciprocal. So our slope perpendicular is going to be +1 over 1. So slope of 1 is kind of tricky, but if this slope rises and runs up and to the left, the slope of this yellow line we know has to be a positive slope. So it's going to be 1. Step 3 tells us to find the midpoint. So we're going to use purple. So the midpoint is when we add our x's, divide by 2. So again, I'm going back to our ordered pairs from here. If it helps to highlight them, I can. Okay. So our x values are 2 and 1. So we have, 2 and 6, x plus x. So 2 plus 6 divided by 2. And then 1 plus -3 divided by 2 gives us that the midpoint becomes, 2 plus 6 is 8 divided by 2 is 4. And 1 plus -3 is -2 divided by 2 is -1. So that's our x value for the midpoint and the y value for the midpoint. So those little m's, just to note that it's x of the midpoint and the y of the midpoint. Now our last step is we're going to take the slope perpendicular and the midpoint, so the slope perpendicular and the midpoint, and we're going to write the equation. So the new line goes through this midpoint and it rises and runs +1, up 1 over 1, or down 1 to the left 1. So for step 4, we're going to use that point slope formula, and it goes y subtract y1 equals m x minus x1. Now we've used the x1 y1 from up here a couple of times. We're not going to use that again. Our line doesn't need to go through point A. It needs to go through this midpoint. So we're going to be using the 4 and the -1 here for this last part. So our substitution will say y minus -1 equals that slope perpendicular is +1 times x minus this x value here of 4. So again, if I clear that up, it says y plus 1, because minus the negative becomes plus, equals 1 times x minus 4. So that's our final equation. That's the equation of the new line. Now again, the last step here says to solve for y if necessary. So when I distribute this 1, we get y plus 1 equals x minus 4. And if we subtract 1 from both sides, y equals x minus 5. So sometimes you'll see answers in this format, which is your slope-intercept form. But that last substitution we made, and I've kind of put a box around, is a fine format to leave this in. So again, equation of a perpendicular bisector, to be writing the equation of a perpendicular bisector, those are like that's your key phrase. When you see those words, these are the steps to doing the question. You have to find your slope of the segment you're given from A to B, the slope of the line perpendicular, the midpoint of that segment, and then we go and wrote the equation of that perpendicular bisector. So we used a slope perpendicular, and the midpoint. Example 2 reads, write the equation of the perpendicular bisector. So when you see that phrase, write the equation of the perpendicular bisector, that's our 4-step process. Okay. Where we're going to find the slope of the segment we're given. We're going to take that fraction and find its negative reciprocal for the slope perpendicular. We're going to find the midpoint of that line, and then we're going to substitute the slope perpendicular and the midpoint into our point slope formula to write the equation of the line. So I'm going to start with a sketch of this segment. So this question reads, write the equation of a perpendicular bisector that goes through the line segment with endpoints -1, 1, and 7, -5. So if I just think about those two endpoints make a segment that has a negative slope. And the equation that we need to be finding is the equation of a line going through this midpoint and a line running perpendicular to that. Okay. So I kind of sketched in a diagram of how this works. So the first step is to find the slope between those 2 points. So y2 minus y1 over x2 minus x1. Then we're going to find the negative reciprocal of that slope. Our midpoint says to add your x's, divide by 2. Add the y's, divide by 2. And point slope is your y minus y1 equals m x minus x1. So our substitutions. y2 minus y1 is -5 minus 1 over x2 minus x1 is 7 minus -1. Gives you -6 over 8. Now I'm going to keep that as 6 and 8 instead of reducing it. Some of you might go to -3/4 with it. Doesn't matter to me. If you make a mistake while simplifying your fractions, you're going to get credit taken off. You can leave it in this regular format all the time. But that slope, we have to take its negative reciprocal. So -6 over 8 becomes +8 over 6 for the slope perpendicular. So that's our m perpendicular value that we're going to need for down here in our point slope equation. So steps 1 and 2 we've done. Step 3 is our midpoint. So to find the midpoint, we're going to add our x's, -1 plus 7 divided by 2. So again, -1 and 7 are the x values. And the y values are 1 plus -5. So again, with these formulas, slope formula has a lot of subtracting, same with point slope, but our midpoint formula has adding. Okay, so -1 plus 7 is 6 divided by 2 will give you 3 for that x value. And 1 plus -5 gives us -4 divided by 2 is -2 for the y value. So that becomes my xm, ym values. So really down here, this x1, y1 isn't back from my original point. We're using the midpoint ordered pairs there. So I just kind of changed this to say y minus y sub m, which is your y value of the midpoint, equals the slope perpendicular times x minus x value of your midpoint, which is going to be our 3. So making the final substitution, we have y minus, the y1 value is -2, equals my slope perpendicular is 8/6 times x minus this x value of our midpoint 3. That's our final answer. We do not need to simplify. We just needed to make the substitutions. So we're going to come back to questions like these next time. What I'd like you to be doing is trying exercise 3 here on your own. You're going to go through those 4 steps. Find the slope of a line perpendicular, find the midpoint between those 2 ordered pairs, and end by substituting into that point slope formula that we've been practicing with the last 2 notes pages. From there, that's it really for the new content today, Notes 109. I do not want you to do classwork 109. I want you to roll back to classwork 108. This assignment is going to be graded. And please, please, please look back to Notes 108 for help. Okay. In Notes 108, questions 4, 5, and 6 here correspond to, in the notes for number 5 here, I want you to see Notes 1.08, question number 4. Okay, so that's what you would have done Tuesday or Wednesday in class. Also, for number 6, you're going to see notes for question number 5. On the notes corresponds to what you do here for number 6. And for number 7, the next page, I want you to see your notes from page 108, question number 6. Okay. With those 2 questions, number 6 here, make sure you get the y to stand alone. So your equation there should read y equals, when we divide through by 3 because they're being multiplied, we get -2x plus 8/3. Now that y-intercept 8/3 doesn't matter, but this slope of this line here is -2. That should help you with number 6. Same kind of case here goes for number 7. You got to get y alone. A couple other things. Slope, midpoint, and length, remember, is the same as distance. So that's from notes 1.07. And last but not least, try number 9 on your own. You're going to need to find your slope from this equation. And then the substitutions should make some sense from there. With number 10, remember, an angle bisector divides an angle into 2 equal angles. So this angle ABD, being x squared, equals angle CBD, 60 minus 7x. Okay, so we want you to practice solving that quadratic there. So I did try to give some hints here. If you have any questions as you're trying this, please send me an email. But again, graded classwork 108, I would be looking for soon. Thank you.